There you go. All right, you guys, we are talking today about composite area. I wonder if anybody in this classroom has ever heard of the word composite before. I can think of sports that use this word composite. I don't know if anybody's ever heard of the word before. Anybody in class think they've heard anywhere in their life the word composite? Because if we have a relationship with it, I used to grow up, we had, Nick, where did you hear about the word composite before in your life? Math, you heard math and composite? What do you mean, Nick? Because realize y'all are throwing some stuff in the chat, and I'm recording my other screen, so nobody is seeing the chat window. So if your mic works, I really want to hear you.
Okay, I have heard composite before, and I think 5th grade, we talked about composite numbers.
Yeah, do you remember what it meant?
It's like the opposite of prime numbers, I think.
Yeah, so prime is a number that's only divisible by 1 in itself. So composite has to be what?
Anything that's not divisible by 1 in itself.
So it would be divisible by what?
Everything.
No, it doesn't have to be divisible by everything. It's divisible by more numbers than just 1 in itself. That's the word composite when you guys have seen in math. Evan put in the chat window, composite versus prime. When I grew up, you guys, I used to like to play a little bit of tennis, and they had what was called composite rackets. That was like the space age, the new technology when I was growing up, because the tennis rackets used to be completely made out of what, Lucas? Wood, yeah. So when they turned them into composite, what does that mean? Yeah, they found a whole bunch of little. You all right, kiddos? You need some moment here? We're on a good video screen here. Oh, you're gonna plug in. That's good. So it's rackets that they took a bunch of different materials, Lucas, and found a way to put them together to make a really solid but light substance. So they have composite rackets now. Composite graphite golf shafts. All right, so they found a way to make a stronger but lighter material. So it's like a fantastic little combination there, but it's made up of a bunch of different items. So when we start talking about composite area, Lucas, here's a problem that I would want you to be able to do on the test. Because you're going to have a formula sheet if you want it, Lucas. But if you look on that formula sheet, there is no area of a letter E formula, right? Yeah. So there is no formula for this object. What the heck are we going to do? Ooh, I don't know if you guys heard that, but Lucas says, what if we break this up into smaller things that we do know how to find the area of? So could you help me start to break this up? And maybe I'll throw some letters on there to make it easier. We got A, B, C, D, E, F, G, H. I don't like I on there. So how would you break it up, Lucas?
I would probably extend like CD all the way across.
Lucas is saying, what if we take CD and we keep it going all the way across? That gives us a rectangle in the top there, all right? Is that all we need to do, or maybe we need to do some more breaking up?
I would do the same thing for segment KJ.
So KJ, do that over there. I think this middle section, I don't know what that, maybe we got to break that middle section up too, because the top, we got a rectangle now. We know how to do that. The bottom is a rectangle. What about this middle section?
I would probably connect E and H.
Connect E and H, so that gives you basically, looks like maybe a square and a rectangle.
Yeah.
So you guys, this was Lucas's attempt to break this object up into pieces that Lucas can handle. You guys didn't have to break it up this way. You could have taken DE and extended it up and gone different directions. But now that we have this, now we have 1, 2, 3, and we have 4 objects. Okay? So does everybody understand? If we took those 4 objects, we found the area of those objects, and added them up, we're going to be successful. The only question is, how do we find the area of each of these objects? And right now, I'm going very slow. I'm going way slower than some of you might do on this problem. But if we see object 1, does anybody know what object, Deshaun, do you know what object 1 is? Is it a triangle, a trapezoid? What is it?
Rectangle.
Do you know how to find the area of a rectangle?
Yes.
Ooh, how do we find the area of a rectangle?
Well, I shall look back through my notes.
Ooh, you actually have notes? There are students in this room that don't have notes. That's fantastic, Deshaun. I'm very proud of you. There's flipping. I hear flipping.
We're going to be here for a while. I have like a line.
What? Come on. What if you had to guess, Deshaun? What do you think? What if you had to guess? And I give you full permission to be wrong right now.
Well, we kind of know I think we know all the angles just because they're supposed to be all congruent. So 3 on that side would be 3 on the other side, right?
Right, but like if I had to write down a formula, what do you so I totally agree the distance from here to here is 3, but how do I find the area of a rectangle? Do you know which numbers you're going to have to use?
Yeah, 8 and 3.
8 and 3. So the formula that you're looking for is base times height. So we just converted it into a quick formula. We might be able to find that base and height pretty quickly. Maybe it's going to take a little extra work. What type of object is object 2, Deshaun? Do you see object 2 right here?
Yeah.
Any idea whether it's a triangle, a trapezoid?
Oh, wait. Is object 2, is it counting the little edged out part? Or is that?
Yes. The dotted lines, it's this confined space.
Okay, that's the rectangle. I thought
it's another rectangle, yeah. So we're going to be able to use the same formula. We'll use different numbers probably, right, Deshaun? But we'll use the same formula.
Yeah.
What about object 3?
It's a but object 3 is a square.
Yeah, and we can either do base times height, or sometimes you'll see this formula, s squared.
The side squared.
Yeah, because in a square, the base and the height are the same. So the formula kind of can look like this also. And what kind of object do we have with number 4, Deshaun? Rectangle. So this is like our own custom made. It looks a little scary, but we custom made our own formula to find the area of this letter E. Now, you guys watch this next move. I highly recommend. Evan, you have a question.
I was going to say, I feel like I've seen problems like this in the past. Like, this seems oddly familiar.
I hope so. I hope this is not the first time you've seen something like this, but we're certainly going to get into this in a high school geometric type rigor. But watch this next move, Evan. I'm going to take all of this custom-made formula, and I'm going to open up all of those places where I can plug in a number. Because some of these numbers might be easier to find than others. And so I'm going to need some help from some people. Valeria, I want you to start off by helping me. Can you find any one of the numbers that need to be used in this problem, Valeria? I don't care if it's the base or the height of object 1, the base or the height of object 2, any one of these numbers, but we want to start finding some important stuff. Valeria's looking. Kylie, you be ready because I got to talk to you second. Are you still there, Valeria? You're not sure if you're there. I see that you responded on the chat window. Nobody on our video can see your chat response, though. All right, Valeria's still looking and wondering. Kylie, any chance you can step in a little bit earlier and help out? Lauren, you're going to be coming next, so be ready, Lauren. Can you find us any one of these numbers, Kylie? We must really be struggling here. Anybody Kylie's struggling. Valeria's struggling.
I can go.
What do you got, Deshaun? You're stepping in.
Number 1's 24.
Yeah, but you're going too fast for me, Deshaun. I just want to plug the numbers in so everybody can see where you're getting your 24 from. Do you know the base of the rectangle?
Yeah.
What?
8.
Yeah, 8. Because the base here would be the same as this here.
That's up.
Yeah, so what's the height?
3.
Oh, so I can see 8 times 3. That's where you're getting your 24. Do you know the base and the height of the second rectangle?
Well, how I figured out the base. Well, not the height, but doing. So there's 2 2s on there, and then if you cut the one that stopped it for the box right there, it'd be equal to 2. So I got 6.
Yeah, so that's 2. This is going to be another 2, and that would be 2. So we have a height of 6. Do you know the base?
2.
The base. Can we say for sure? Because I'm starting to look at it, and I'm wondering, did I put us enough information? I think I should have added. Let's go ahead and say, I'll add one more number here. I think I probably should have told us what this is. Then if that's 6.
Yes, the base is 2.
Yeah, then the base. I'll confirm your value of 2, because if this is 6, the rest of this would have to be 2 in order to make 8, right?
Yeah.
There you go. Sorry I left out a number there. Doing great. Do you know the 2 sides of the square?
So it's 2 squared, right?
Yeah, because 2 times 2 would be base times height. 2 squared, same thing. Now what's the base and the height of the bottom rectangle?
The same as the first one.
Which is 8 and 3. So now we were able to open up. Not those numbers really weren't that bad to find, but this became easier because Lucas and Deshaun helped us come up with our own custom-made formula. So what should I do next, Deshaun, to try and work on this?
Do the math for them, do the multiplication, then add them up.
Yeah, so so 8 times 3 is 24. 2
Next
times
one's 12.
6 is 12. 2 squared is what?
4.
And 8 times 3, we already know that is 24. And so my next move is what?
You're gonna add them all up.
Yeah, I got 36, 40. I think that adds up to 64. Now remember, this is an area, you guys. So if all of these were feet, Deshaun, do you know what the units would be on an area?
64 feet.
Feet is a linear idea. Area is like if we had paint in a can and we wanted to cover this. So area is 2-dimensional, which means because every time here we're doing feet times feet, we're doing that over and over, which is feet squared.
Okay.
Fantastic. I had some really good help there on finding that composite area, but let's throw a little bit of a curveball into this one. And look here. I don't know if you guys know, but us teachers are really rich and we have like land everywhere because we have all this disposable income. And out in the country, I got myself this little lake that I bought. I don't know how big the lake is, but my insurance company wants to know so that they can appropriately charge me a vast amount of money and bleed me dry. So what they did is they sent a helicopter over my lake and they took a picture. And we've overlaid my lake over this grid. Now this grid, every one of these measurements is 1 mile. So a horizontal block this way is also 1 mile. Does anybody have any idea how I can find the approximate? I want to get an approximate area of Lake Foss. Does anybody have a plan that might get me pretty close to the answer? Any ideas? Evan doesn't. He's struggling a little. Nobody has any ideas. Hey, Connor, I got a question for you.
Yeah.
Connor, do you know what is the area of one of these blocks that I have here inside the lake?
Wouldn't it be 1? Because it's 1 times 1.
1 times 1. Now just realize that each of those blocks would then be 1 times 1. Miles times miles is miles squared. So we have 1 square mile for every one of those blocks. Remember, we're just looking for an approximate solution here, Connor. Any idea how we could find out how many blocks are inside that lake?
Count the blocks inside.
Well, yeah, we could just, because there's some solid blocks that are in there, right? So let's go through and start counting those up. Now, I don't want to color them all the way in, so let's go. Looks like I have 1, 2, 3. I already colored number 4, 5, 6. That's probably a full one, close enough. That's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Looks like I have about 29 square miles in full blocks. Is that going to be a good enough answer, Connor?
Probably not.
So what am I going to do about all of these that aren't full blocks?
Well, the 2 on the top left look like they're halved.
Does everybody see? So how much would I have if I put those together?
1.
Yeah, so watch that. I can kind of go, right, well, I'm going to take those, and I'm going to start kind of like keeping a tally here. I got 1 more added to my total. So here's the easiest way for us to communicate, Connor. I'm going to give you rows. 1, 2, 3, 4, 5, 6, 7. There's 9 rows and 6 columns. Can you show me, in your opinion, your professional mathematical opinion, where I could do that again and put some blocks together?
Row 6. Column 6, rows 2 and 4.
Rows 2 and 4. And anybody can come in here and disagree with Connor, but I think that's pretty close. This is maybe a little bit more than half. This one's about half, but I'll go with you. We added 1 more to the total. Where else?
Row 8, column 2.
Row 8, column 2. What are you going to put that together with?
I'm not honestly sure.
Do you see? Because that was about
row 6,
half.
column 6.
Row 6. Row 6, column 6. I don't have anything in there.
I don't know. I'm not very good with this.
Anybody think they can help Connor out? Anybody see any others that we could put together with row 8, column 2? Nobody sees any other halves. Valeria, you see one?
I think there's one in the
So if you'll tell me a row first and then tell me a column, I bet I can find which one you're talking about.
minus 3.
Row 3, we have all those taken care of.
No, row 4.
Row 4, column 1?
Yes.
Oh, I like it. There we go. That's another half one that we can put in here. Do you see any others that we can put together? Maybe I need to zoom in. Because we want to try and get everything accounted for. Do you see this little piece right here, Valeria?
Yes.
I got row 5, column 2. If we can find one more little half, then we might have one more to add in.
Column 7.
Row 7. Oh, yeah. Good job. That's probably enough to make another one. And I see only one more. There's one right here that I don't see any others. Anybody see one that can go with? Because maybe we have a half left, I think. So now that we had Connor's idea of adding up all the full blocks, then we put all these part ones together. 29 plus 4 is 33. I think a good approximate area would be 33.5 square miles. So not everything has to actually come out to shapes. We can be approximating like this. Otherwise, you can try and find different shapes that live in here and do a bunch of different area formulas, but I like Connor's idea here, just putting some of those pieces together and coming up with a good area. Okay, so let's go back out here. And one more to take a look at. I think this is a little bit more different, a little bit, because this is now, we only want the area of the shaded region. Luca, what kind of shapes do you see there? Because you probably shouldn't have your phone with you. I've already asked you to put it away once. Don't worry, if I have to ask you twice, then parents can come pick it up.
Square and a triangle.
Square and a triangle, but I only want the shaded region. How am I going to find the area of the shaded region? Am I going to try and take the square and add it to the triangle?
Nope.
What am I going to do?
You're going to subtract the triangle.
Does everybody see? Luca just came up with a plan. This is not even a formula. This is a custom-made Luca plan. Do you know how to find the area of a square, Luca?
No.
Must have been playing on your phone because we just had that written down. Deshaun took care of that for us. The area of a square is side squared. Do you know how to find the area of a triangle?
No.
We should probably have these notes. Kadis, do you know how to find the area of a triangle? It's 1/2 base times height. So now again, the only way to do this, look, will you mute yourself again? We got some nice reverberation going, is we had to come up with a custom plan to go after these problems. There's only 3 things I need in order to be successful here. Question is, do we know any of these numbers? Pablo, do you know any of these numbers? Do you know a side of the square or the base of the triangle or the height of the triangle? Yeah, the size of the square, that was right there, 12. Now we just need to find a base and a height of this triangle. And I think the only way we're going to be able to do that is we probably need to be able to look at the triangle this way. We're going to need to find the base here and the vertical height of that triangle. Does anybody have any idea what those pieces might be? Lucas, what do you got?
Is it the square all the sides are the same? So that would be 12.
Yeah, so I think that dotted side there, that base of the triangle, we can use 12. What are you going to use as the height?
The 8.
The 8. Now that we got all our numbers plugged in, Lucas, what do you think we need to be doing now?
I just plug them into the formula.
Math it up, yeah. Do you know what 12 squared is?
144.
144. That's smart. Do you know what 12 times 8 is?
37.
Are you using your fingers? Do you know how to use you know how to, no?
I know my fingers are the 9, not 12.
Yeah, the 9s are the fingers, but 12 times 8 is, you know what 10 times 8 is?
That's 80.
And 2 times 8, you can split them up, and so you got 80 plus 16, which is 96. And I'm sure you know what half of 96 is. Look at the screen.
48.
Yeah, Lucas, it is 48. And 144 minus 48 is going to be, obviously, and whatever our units would be, we would want units squared because, again, we're doing an area problem. Okay, so even though we're talking about composite, we're not always talking about adding some things up. All right, but it is still think of it as a combination of multiple shapes. And this is not the only way to do this. This is just Luca's good idea. You could have split this up and looked at a trapezoid here and a trapezoid here and then added them up. There's multiple different ways to do these problems. Okay? So, thank you, second period, for helping make this video today. I hope the rest of my classes find this useful and educational. All right?